So this is part two of kind of the deep look at what is involved in making most common SLRs. So what we're going to be looking at today is we're going to look at the electronics in depth, you know, kind of take a much closer look at some of the various sensors, the autofocus sensor for one, and I'm also going to just take a look inside this top panel, just because I think I have not looked into the housing of the flash, so I'm going to do that first. Mostly because I expect this to be fairly interesting. I think they're, considering all of these leads, the trigger transformer for the flash actually I think is mounted up in the flash housing. You can also see it appears there's an autofocus assist light. So we'd like to see into the LCD. So this, as an aside, is the two-stage exposure button. So you can see that I believe it initially breaks contact. I'm not entirely certain. No, I'm sorry, it holds it. So that what happens is this is held a little bit like so. And then the first step makes contact with the intermediate step, and then it pushes it into the secondary section. It's another big, complicated, bent sheet metal thing. Because apparently that's what Nikon really likes. There's this little cover. Ah, there we are. Yes, so we do indeed. So you can see right here, that is the trigger inductor for firing the flash. And then these two yellow leads appear to be the connection for the focus assist. And the red and black leads are indeed the power, or the high voltage to the flash. So it looks like they don't have any readily apparent facilities for quenching the flash, so my guess would be that they adjust the flash power. Well, it's doing TTL, so they must have a FET somewhere that can interrupt the flash current, you know, in flight. Interesting. But yeah, so there's just the little flash bulb. There's the firing inductor, which just has one, you know, it just generates a high voltage charge that's applied to basically applied across the exterior of the flash bulb. And that induces ionization within the flash, and that's what makes it fire. And then over here we just have a little incandescent, I believe is how most of these work. Does that pull out to the front? Yeah, it does. Yeah, so it's probably 3 or 6 volts. Yeah, it looks like that's a 6-volt thing. That is a bright little sucker. That is 6 volts right there, yeah, so that's your AF light. Cool. Actually, what's the power on that? So at 6 volt, which is what your 2 lithiums in series are going to give you, that is pulling, wow, 0.42 amps. 0.42 to 0.43. So that's a 3-watt light bulb. That sucker's going to get hot. I guess they probably have limited duty cycle. Yeah, it's warm. And then the rest of it is just... So here's the LCD panel that goes kind of in the top panel. And one of the things you can see is it actually looks like the LCD is a separate module. And then I think it's probably hot bar soldered right here. I just take off this little bit of tape. Yep. So actually, why don't I desolder this so that we can separate the two? Just kind of put tension on it and just slide along, and there you go. So yeah, that's just a good old-fashioned hot bar solder joint. You can see some of these flux rigid assemblies. There's a little stiffener. So this appears to be the LCD with another flex cable just running underneath it, which is kind of redonkulous, but there you have it. So yeah, this is definitely, oh, correction. So this is the input. It comes in on this flex cable here. And then apparently this is the main interface, and then here are your buttons. And then there's the LCD. And then here is MB89151, and there's a little RTC crystal from the look of it going into here. You can see this is all flex. You can see their teardrop. This is a dual layer flex too, which is pretty amazing, interesting. Well, not amazing, but interesting. It's a 4.19 megahertz resonator from the look of it. There's more little oddments everywhere. So this is the interconnect for the flash. So I bet that's a high voltage transistor, because some of the flashes can have several hundred volts on their central pin. I'm kind of surprised there's not more creepage around the central pin though. I guess that's a diode, considering two of them are in parallel. And these are just the TTL contacts. So I took the little metal plate off of the LCD, and it now comes loose. You can see here's the cable that went under it. So this is kind of interesting. You can see it's a flex assembly with a number of heavy traces and a whole larger number of very narrow traces. So, you know, presumably you have two power rails and ground, or several ground connections. I'm not entirely certain. Interesting. Coming over here, you can see here is the little LCD, and there are your interconnects for the LCD. They all route back to this chip here, so this is going to be LCD driving. One thing that's very interesting about this that I haven't seen before is, so most of these use kind of these single directional conductive elastomeric interconnects, and on this one, you can see how it works. So the way these works is you can kind of see it's a rubber, silicone rubber type compound, and the dark sections are carbon doped and the light sections are non-conductive. So what happens is it's effectively conductive along the dark doped sections. So it's conductive in this axis but not along this axis. So what they do is they have, you know, an array of, you know, whatever the vacuum deposited. You can kind of barely make out each of the little two connections in the shift in color. I don't know if you can tell, but there's like one there, one there, one there, one there, one there, one there. It's very hard to see. Actually, let me get a light background. Which is actually the conductive material deposited onto the glass. That's more apparent. And you can kind of see they're spaced equidistantly. And then what happens is this material just conducts along this axis, so that then what happens is when this is smooshed up against these pads, you get a connection. Because if you kind of compare the two pitches, the pitches for these two are the same. You know, it's the same pin pitch. You know, the conductive section on there is the same pitch as the pin section here. So that's how it connects through. And then they just kind of smoosh it together, and then because again this is an LCD, which means the driving current is absolutely minuscule, you know, just the carbon doping is plenty to conduct along there. Actually, there's an interesting idea. So I have my ohm meter here, and let's just kind of go bleed. Oh, that stuff's pretty conductive. So just across those 2 points there is 150 ohms. So this is, I mean, you know, of course, and also like that, it's infinite. It's above it's probably in the mega ohms, maybe. This meter only goes up to 60K. But I mean, you know, so there it's, you know, depending on how hard I squish, right now it's, you know, it's like a K, half a K, and then as I smoosh harder, it drops to 120 ohms, you know, 74 ohms. So obviously it's heavily dependent on how much pressure you're putting on it. But that's plenty. You know, LCD bias currents are incredibly minuscule. So there's just kind of a cool example. I've seen these before, but I hadn't seen one that had the, you know, didn't have it, you had it visible. And as you can really see the, you know, kind of the striated layers. I can feel them with my little dental pick too. Okay, moving on. Put that aside. So we have lots of other interesting things. Here's this flat flex abomination. You can see 1, 2, 3, 4, excuse me, 1, 2, 3, 4, 5, 6, 7, 7 stiffened sections on this one flat flex assembly. You know, and this is probably the main controller thing. You know, this is a, I think that's a Hitachi HD6433388F8 Japan. So we have down here, that looks to be a 16 megahertz resonator. That's probably a tant or an electrolytic, another tant or electrolytic. You can see, look at the beautiful traces on here. You have to do curved traces because any, on flex, even apparently on the rigid sections, you have to do curved traces because any sharp angles produces like a stress riser, and then the trace will tend to crack there. This is interesting. You don't see these very often anymore. This is, I believe, actually a tantalum capacitor. And this pip, this metal thing poking out of one end, indicates the positive end of them. These are an unusual, and I think they're fairly high-spec tantalum these days. At least the only way you can buy them these days is high-spec. You can see here, this is this was actually where one of the other flex cables, I don't have it, sat on here and had two hotbar edge soldered junctions. And then this section here was actually not populated. I don't know what that was for, probably a different camera model. Just over here you can see here we have, so this I believe is, it's a Hitachi part again, and I believe this is the COM interface for the autofocus sensor. So this is probably like AF involved. You've got some little SOP323, I believe is what they are. I don't know what any of this jazz is. I forget. I think this was, oh yeah, this was the AF motor right here, I believe. So I bet these chips work together to deal with the AF somehow. This was that accessory connector on the front panel. I don't know what it is. This is a D16805. We see this in another place, actually. The other motor driver was also a D16805. I think this is it. Yeah, so this is the other motor driver. I think this drives the film advance. So it looks like the D16805s are both motor drivers, and I bet this is the integrated AF chip, you know, or at least the digital end of the AF chip. So this is very interesting. So what we have here is, yeah, so this indeed looks to be this is the basically kind of the readout panel in the LCD, or in the, excuse me, in the viewfinder. And I bet if I stick 3 volts on there, or well, so I would bet that this is basically a little tiny backlit LCD, or something along those lines. So if we follow these traces, so we have these two somewhat heavy traces which wrap, go like that. This may also be involved in like imprinting the date code onto the exposed image. So they go there, it looks like it's probably switched. Let me just try sticking 3 volts on there. It'll either work or it'll blow up. It's drawing current. So I guess the real issue is, can we look in the front while I'm doing that? So, yeah. So that is an LED. So however that works, I bet this is, yeah, so it's just a little LCD display that probably tells you like your exposure, compensation, and so forth. And this may also be involved in, yeah, I'm not too sure, you know, I mean, it may actually go dark and only illuminate the section. I'm not too sure how it works. But yeah, so this is the readout LCD that sits in the, you know, in the lower section of the viewfinder. And then where you have your, you know, so here's your viewfinder window, and, you know, here's your, you know, your spot metering and your AF point. And then always on the bottom section here is like, you know, your time, and the exposure time, and your, you know, your f-stop, whatever. Anyway, so yeah, that's quite cool. So I guess that's how that works. So now we get into the more interesting things. Actually, I am going to cut this flex just to make my life convenient. So this is the metering sensor. It is, as usual, soldered together for some bizarre reason. And of course, then they put sticky tape on the solder. It's going to smell utterly horrible. I'll do it fast as I didn't. So this is, you can see, it actually looks like we have a many quadrant photodiode. So I suspect strongly that we have 1, 2, 3, 4 quadrants, spot metering, and then, you know, this is your interior spot meter. And let me see if I can figure out how this case is held on. It appears it's actually bonded on. This is very, you know, I think this thing has, like, I looked it up, it had a number of section metering, but I suspect we can probably figure out, you know, how many metering sections this has just by looking at the sensor. Oy. It wants to come loose. Oh, bother. It's got these stupid ass little metal ears. Alright. So, this is one specialty son of a bitch right here. So that is a... Oh wow, look, it's got all the readout electronics in there too. Hang on a second, let me figure out how to get this closer to my... So this is the metering sensor, which it possibly has a whole bunch of involved, you know, control electronics in it as well. So you can see you have, so the dark section here is your multi-sector photodiode. You got 1, 2, 3, 4, 5, 6, 7, 8. It looks like this has 8-sector metering. Actually, I have the website open. It was introduced in 1994, so it's not as old as I thought it was. 8-segment matrix sensor. Yep. So there you go. So that's, when they say they have, you know, 32 quadrant metering, that means there are 32 separate segments of the meter. In this particular situation, we only have 8. So you can see, you only see all 8. And I believe this is it doesn't look quite like the 35mm aspect ratio, which actually kind of surprises me. It definitely appears that this is, like, there's some other stuff in this, in the package. You can see that you have, like, your metal, I think, and then there's a fairly large chunk of silicon, and it looks like there's a bunch of circuitry down there. So there may be, I mean, you can kind of see some of the metallization patterns on the surface. So that may be involved in, look at that, you can also see there's little lead frame stubs up at the top section. That's kind of amusing. So I bet that's analog readout, or possibly everything. There may be analog digital conversion and everything in here. But that is what the metering chip in an 8-segment matrix metering chip actually looks like. Let me take some exposures of this. So I'll have some high resolution images of that available on my website as well if you're curious. So this is the really thing that really kind of interests me the most. Well, first of all, actually let's kind of taper a lot up. So what we have here, this is the TTL metering IC. So what this does is this looks at, you know, it actually points at the sensor, and then when this shutter is open, it measures the light reflecting off the, film. You can tell I'm too used to digital. So this measures the light reflecting off the surface of the film during the exposure, and then terminates the flash or exposure at the appropriate time for, you know, to properly expose your film and or sensor. So you can see it's got 3 little lenses on the surface, and I'm not sure if it doesn't look, it looks like there's a separate sensor IC down there Though there, it also appears, I think what's going on here is that blue glass, I'm about 80% sure, is just an IR filter. So, yeah. So you can see that just came loose. So we have, that's interesting. So you can see here we have a, this is just like an infrared filter and like an aperture mask of some sort. Here's the actual lens assembly, which just has 3 little micro lenses. And then here's the actual metering chip. So what I would bet is going on here is this is looking at one half, this is looking at the other half. Oh wow, that's interesting. Look at this. So you have spot metering for TTL exposure, one half of the matrix metering for TTL exposure, and the other half of the matrix metering for TTL exposure. So I bet they're all used for matrix metering, and then you know if you just have, depending on your configuration. So this also, we can also see, looking at this, that this has 5-sector TTL metering. Let's look closer again at this. Let me just kind of rest my hands. Grab it with the tweezers. So here is your matrix metering control chip, and you can see, again, there's a lot of electronics on there that are masked off. And it's also kind of critical to remember that this optical mask was going to be sitting on here. Oops. Kind of like so. Assuming I can align it properly by hand, which I can't because it's freaking tiny. Ah. Or I don't just drop the whole thing outright. So this was, I would guess, sitting on there in some manner to kind of mask off, or to possibly, oh, I bet I know what this is doing. This is preventing light from one lens from making it across to the other ones by masking it. So the issue is that with these lenses, I would bet if you have, you know, like a lot of light bouncing around and coming in at a particularly oblique angle, it might like bounce back and forth within the, you know, you get like internal reflections within the IR filter, and then it would probably cause the other metering section, or the other TTL metering sections, to read input correctly. So that's why they have these mask sections. But yeah, again, you know, the same thing. You can see lots of, you know, you can make out the circuitry a little bit, and you can see the 5 photodiodes. Anyways, so those are the 2 metering ICs. There it is. So now the thing that interests me the most is this. And we'll probably try and set up a better macro imaging session for those other 2. But in any event, here we have the autofocus sensor. So you can see the main autofocus slot is horizontal in here, which is why there's this mask assembly here. And the sensor is actually down here, held in, you know, covered by tape and held in by glue, which is exactly how it was done on the D80 when I tore that apart. I wound up gluing it back together with Elmer's glue, and it worked. So there's the actual AF sensor in there. I expect a horizontal linear CCD in there. So that's interesting. It appears they're using this tape as light blocking. So there's also, it looks like there's going to be a mirror in here. In fact, I suspect that's strongly what's under that cover there. So now that we've started to get in here, let's pop off the first lens. Right. So we have like a little retention clip, and here's another mask to kind of control the angles of the light coming in. And then we have, this is just a lens, focusing lens. And then just down here we just have, this mirror is held in. Oh, I see, it's held in by like a spring. That's interesting. It looks like it just drops in. So these 2 releases on the sides here, and So this is kind of something of a moment of truth, because it's going to basically tell me whether or not I actually know how phase detection autofocus works. So there's just, you know, a little retention clip. So here we have a, well, that's unusual, that's a front surface mirror. So that's like a high quality mirror right there. And then if we look down in here, haha, there is your aperture mask. So that's interesting. It looks like they have, okay, I think this is a cross type autofocus point. Because, well, if you notice this, that's definitely cross-shaped, but one thing of note is that this is much wider than this section. So I bet horizontal is like 2.8 or wider aperture, and vertical is probably f5.6, because it's not, again, if you remember back to the drawings, the issue is you know, you have, let's see, where is it? So you have your focal point and you have your multiple rays. And basically, as your aperture gets smaller, you know, basically you're only looking at the rays across a narrower section. So again, you don't get as much split after going through the autofocus system. So I strongly suspect that this is 2.8 in one direction and 5.2, or, you know, and f5 in the other direction, or something along those lines. So I suspect that what we're actually going to see in here is a cross, two linear CCDs in like a cross arrangement. So anyways, so that is the little mask, and then actually one of the things you can see is that if you look, it's not really that easy to see, but there's, and it's hard to, I can't really show it on the camera, but there's glass in there, and that glass has a distinct bluish tint, which means that that's where the infrared filter is, which is actually where it was in the Canon, in the other Nikon I've torn down, and that was why I wound up having to take the autofocus sensor apart in that one as well. And I did take pictures, which I will probably incorporate in, and they will, you know, do some voiceover commentary on them. So this is some very hard glue here. It looks like it's somewhat, it appears the way this works is the sensor is glued, so the sensor has like a rectangular ceramic tab on the bottom, and that is glued to this plastic. So I need to get in there, because the ceramic is extremely rigid. Once I kind of start peeling it away, it should just pop loose, unless I'm breaking the ceramic. Right. I just don't want to put the knife through my finger. I just broke the ceramic. Man, this is one stubborn son of a bitch. Looks like I can kind of crack the ceramic back a little bit and then maybe pry. Ha! Suck it. So. Blah. Blah. What the hell just fell out of my lamp? Anyways, so just stuck my finger right on the cover glass. So here is the AF sensor. So if you look, so yep. Hello. So what we have here is it's a multi-segment. You can see here's one linear segment and here's the other linear segment. I'm not entirely certain how this works. I guess if they measure the phase offset here, they can figure out how far they have to drive it to be centered, or they can possibly detect it in both directions. But you can see here, yeah, so I guess but yeah, you can see here the two linear segments. Let me get a better look. So you can see here that, again, the dark sections are your linear CCD or CMOS array. And so what happens is the two spots fall on these sections here, and once they see the two sections, the two spots, they know exactly how far out of focus the lens is, and they can just drive it the rest of the way. I'm still not entirely certain how they determine which direction the lens has to go. I guess if you just move it at all, you can determine it, and then you just measure it, or maybe they know, I don't know. But yeah, so that is the linear CCD array from the N70, the Nikon N70 SLR. And you can see the two linear CCD sections, and I don't know where the readout electronics are. I don't think they're in here. Well, they could be. I mean, there's obviously a huge amount of, it's a large die, and I mean, that's partially because they need a fair amount of die area just for the CCD segments. I keep saying CCD, it could very well be CMOS. But I don't know why they, I would imagine that a lot of this stuff is probably readout. It's, again, as you can probably tell, there's 4 segments. So I bet those 4 segments are read out separately, though I don't know, again, there's some questions. You can see the gold bond wires. This one appears to be much less aggressively masked than the other two, which is interesting. I would guess that's because they're kind of controlling where the light is falling to a much greater extent. But yeah, so you can see how they can, it can determine light position along these 2 points, a small spot there, and you drive it a little bit this way and it moves that way, and you can figure out exactly how much further you have to go to bring it all the way into focus. So that's just a cool little example. I mean, there's what, your modern AF sensor in your normal camera looks like. I'll probably stick the image in right now. You can see it's got a lot more linear CCD segments, but it's the same, the same general affair. So I will just stop here for a second and take some high resolution images of this. So there you are. I hope you found this this completely in-depth teardown of how an SLR works. Quite interesting. I mean, well, how an SLR and how the autofocus in an SLR works. So here we can see, so you can see the 3 little quadrants there. And actually, I believe if I pull this plastic section out, there's actually 4 little lenslets in here. So I don't know where it went. Where are my tweezers? So here is your little aperture array. So the 2 wider ones on the edges of the hores are the much wider ones, and the 2 small ones are the 2 vertical ones. And then here we have, this is the lens assembly that focuses those points down to a much more precise spot, I would guess. I'm not entirely certain how it works. I'm a little out of my depth with some of the optics, but it's a little like a almost wanted, coulda, shoulda, coulda, woulda been a fisheye lens in a previous life. Anyways, there you go. So I mean, that's what's inside your autofocus system in every camera you've ever, every SLR you own.